I'd like to spend a few minutes talking about the second of two projects that the Atlas Center has funded to help us understand the problem of driver distraction. It's fairly clear from lots of literature that driver distraction is an issue, that there are lots of crashes that occur because drivers are distracted, in particular by in-vehicle devices, the radio system, the navigation system, and other systems that are inside the vehicle that require the driver to look down and perform tasks, taking their eyes away from the road. Now, there are a number of ways that this problem can be assessed. The federal government has a process that involves visual occlusion and also a process involving a driving simulator. However, it's pretty clear from the literature and from lots of other evidence that a major issue that affects distraction is how long the tasks take. How long does the driver spend looking inside the vehicle? In addition, this is a problem of particular interest to manufacturers and suppliers because they're interested in making these interfaces usable. And probably one of the most simple indications of usability is the time that it takes to perform tasks. So for both usability and distraction, task time is an important measure. One way that that's assessed is to use SAE recommended practice J2365. Now J2365 basically has a table of times for actions such as pressing keys, thinking, and so forth, and one estimates the time to perform a task by breaking it down into steps, identifying which element is associated with each step, adding up the elements, and then coming up with an estimate of task time. A huge advantage of this method is that it can be performed early in design when one has what's known as a wireframe, basically just a sketch of the interface. And this is often months ahead of when a physical interface is working, the hardware and software are in place, and one can do a test with drivers. And the big advantage of being able to do it at the wireframe stage is that it's much easier to make changes at that point when it's a physical interface that it already exists. Usually the usability test comes at the last step, and often it's very difficult at that point to make changes because there's a push to put something in production. Right? Given that problem, how do we use SAE J2365 to assess contemporary interfaces? And therein lies the problem. J2365 was developed about a decade ago, before contemporary interfaces existed, in particular those with touchscreens. So what we did was to look at some data that we had from a recent study that we conducted for Chrysler to look at touchscreen operations. In that particular experiment, we had 24 subjects, and they performed 14 tasks, a total of, depending on which task, up to there were 40 trials. So we had pretty substantial data on what people did on a second-by-second basis, both task time data obtained by an electronic recording system, and also we had videotapes of what people did. So we went back and reanalyzed these data. And in particular, we're interested in operations such as dragging, using a cursor, and other kinds of activities that simply were not available prior to touchscreens. And so we reanalyzed the data. There were several thousand data points. And what we did is we determined the mean time for the various operations. We determined the distributions and other information about them. And this information will be used to revise SAE J2365. One other interesting thing that we did is we sort of rethought how you do the calculations. So in previous analyses that are traditional with using 2365 and other models on which it's based, in particular the keystroke level model, there's an element in there called mental operation, which is the time required for a person to think about doing a task. And the difficulty is it's not clear when that thinking occurs, and the rules for them are quite complex. So as a consequence, we got rid of that element and folded that time into the other elements, namely using cursor keys, dragging, pressing and holding keys, and so forth. And I think that'll make the analysis much simpler to do. So the end result of our work is simply a table of data. And the table of data has the mean times for these elements, their distributions, and other information. And that information will be used with some additional analysis to revise SAE J2365. Probably not in this go-around, but in the next go-around. If you have any questions, please send me email at pagreen@umich.edu. Thank you.